Welcome to Video Bytes. Today I've got Dinesh Dutt. He is the CEO and would rather be known as an engineer, honestly, about SuzieQ Enterprise. SuzieQ is the product that Dinesh has been working on for quite some time now, and it is designed as a tool for network operators to rethink how you think about your network and interact with your network. Uh, Dinesh, we're going to talk through some common use cases for SuzieQ Enterprise in our production environments today, and then show off some of the tools and features that SuzieQ Enterprise has that people get a good sense of it. Where do you want to start today?
Thank you for having me, Ethan. So SuzieQ, as you pointed out correctly, is a way for you to rethink your network. And very specifically, what I mean by that is today, most network engineers tend to think of network as a sequence of boxes or a set of boxes. What SuzieQ allows you to do is to think of your network as a system, a distributed system. Networks are the first distributed system. Now you can think about the network holistically in a much more integrated fashion than you can before. That said, today SuzieQ Enterprise is being used in organizations ranging from campuses to data centers, from Fortune 100 companies and to privately held, from industrial warehouses to data centers, etc. So in across all of them, and from small like 20, 30 devices all the way up to 3,000 devices or so, and across fairly large, well-known brand names. I unfortunately, of course, can't say what they are right now for confidentiality reasons, but we have quite a few, and we've been adding at a pretty steady clip in this last few months. With that said, what I want to focus on today is what are the top use cases in production that I see over and over again. And while there are lots of features that I can talk about, I want to just focus on a couple of them to give a flavor of what people can do based on what I see a lot of people showing interest in.
Okay, kick us off. I'm interested in what the top use cases are as people have been using this tool.
Got it. So the primary use cases that I see, and the first one is secure system-wide view across time for all teams. And what this basically means is because we offer in the enterprise RBACL, whether you're using the CLI, whether you're using the REST API, or you're using the GUI, basically we allow people to have access to information, not devices. One of the most common problems I hear from people over and over again is the senior engineers are clobbered because they are busy setting up user privilege levels all the time because they have junior engineers coming in wanting some information and they're terrified they're going to screw up the box. Or they have cross collaboration. They have someone else from another team wanting information and they become the conduit or the bottleneck through which everything flows. Instead of that, if they can provide a secure system-wide view for all that information without providing access to boxes, that'd be fantastic. So a most common use case is to offer secure system-wide view across time for all teams. The other very common use case is network refresh redesign. And we have a very interesting validation model that pretty much everyone we have been showing it to and all our customers have been using very effectively and are very pleased with how easy it is to use them. It's a declarative model of talking about your network. It is not how shall I say, programmatic. You're not specifying loops and in devices and interfaces. You're just saying, here is what I want to assert about the leaves in my network. Here is what I want to assert about the external facing uplinks in my network, etc. And we go validate all of that. The other use case is network documentation, which is basically our integration of SuzieQ with NetBox in order to be able to do all kinds of interesting things. Now, there are tons of other use cases like audits and compliance and proactive health checks, but I'll save those for another time. So for now, I thought I would just focus on how we help with the secure system-wide view, the low-code, no-code validation, the network documentation, and how we specifically look at refresh redesign.
Sounds good. I am keen to get going. The system wide thing is a big deal to me, so I am actually quite excited to see this.
Okay, so I just want to show you this topology. Everything I do will be largely based on this topology. It's a pretty standard data center topology where you have a pair of dual attached leaves, a couple of servers. Two of them, server 102 and server 302, are in the same VLAN. The other two are in different VLANs. It's a leaf spine fabric running
Yep.
EVPN, going to exit leaves, firewall, and a data center edge. So this is just basically the topology I'm going to be working off of. I'm going to keep switching between CLI and GUI because one of the unique things about SuzieQ is that we offer a CLI. As far as I know, almost no other tool offers a CLI. And it's a CLI that I think is particularly interesting because of the fact that it is very network friendly. And
Mm.
pretty much every one of our users has started with, we are GUI people. We like a GUI. And once they get their hands on the CLI, they've been just going nuts with the CLI because of the
I'm
fact that
surprised you. I was not expecting you to say that. I expected the opposite. We're CLI people. I need a CLI, but to start with the GUI and then end up at the CLI and learn how awesome the CLI is, that seems backwards to me. But I guess maybe I'm getting old, Dinesh.
I think because of the fact that a lot of network management, if not all network management tools today, give you just a GUI. That's what they're
Mm.
used to.
Yeah.
And my personal opinion has been if you look at all the complex systems and the admins that they do their job, even DevOps for that matter, they are all run off of a CLI. Very few of them, GUIs are usually for point and click. Don't get me wrong, GUIs are fantastic for topology. If I want to see a topology, nothing
Yeah.
like a
Of
GUI.
course.
So
Yep.
I know, and people are not going to the CLI because our GUI is kind of not so good. I'll show you the GUI too. But the reason why they do it is the power that they can do and how quickly they can type instead of point click to get to something is so much faster. So with that said, let me kind of switch to the CLI for the first part of the demo. So basically, you can see that I'm connected actually to the REST API. So you can see at the very bottom of the screen here, something that says engine, and you see a URL there or an IP address and a port.
127.0.0.1 colon
Yep.
8000. Yep.
Yep. So basically, even though I'm using the CLI, it's going through the REST server. So everything is, we eat our own dog food. So everything goes through the REST server. We can also do local access, but everything goes through the REST server. So with that, let's kind of start with something that I see very commonly a problem with. A lot of people present information, but imagine a user who has got 3,000 devices, which we have a lot of users
Mm.
doing that, or 700 devices, easily 700. So when I see these users, how are you going to look at that kind of information in a way that makes sense to you? Because we can have 7 pieces of information, they say, in our head before it starts to all kind of make a mess and cognitive overload sets in. So one of the things we have tried to focus on every time is to present information in a cohesive fashion. Think of it almost like Google Earth. You can zoom in and zoom out all the time. So with that, let me kind of give you a simple example. Everybody shows you interfaces. Nobody does anything different. And you say like, hey, I know how to do interfaces. But here what I want to do is show you interface summarize, which is something that we offer. So summarize is a command we offer that summarizes the information for you so that you can try and make sense of it. And let's start with something that's very common to network operators, an MTU. So you would say like, hey, as a network operator, I've configured my interfaces on MTUs. I have a couple of MTUs and that's all there should be. So you hit interface summarize, and what you get is a list of information. You see that there are about 10 devices, 174 interfaces, devices with a bunch of things. And then if you look at the
Mm.
unique MTU count, it says there are 7 MTUs. You say,
But I should only
what?
have two. Yeah.
Yeah, I thought I had two. I had one for loop back. Okay, fine, one 1500, and maybe one for the uplinks because I'm running EVPN network. Where did the others come from? Well,
Mm.
maybe one more let me add towards the server. You're kind of now coming up with all these excuses. This is unexpected to you. So what do you do next? What you can do again with SuzieQ is you can say, hey, I want to see the unique values of, and you'll see here, one of the things about the CLI is it's completing for you as you're typing. So if I
Mm-hmm.
say column, it gives me a list of what columns I can type. And I can type M, and there is MTU sitting right there. You can say MTU, and you can say, show me what are the unique values. And there you see a bunch of different unique values. You say, what?
Mm.
I have 1500, I understand. What is 1514? What is
Mm.
9164 and 9214? And what is 65535 and 65536? You see, before you've done anything else, you've already started to see interesting aspects of your network that most people just don't anticipate. They think they know. And this is one of the things that I keep hearing people is like using SuzieQ is turning on the light. We thought we knew, but we realized how much
Mm.
we didn't.
Oh, I would have
So
been that guy that totally told you, I know. I mean, I built all these, Dinesh. I know exactly what's in there. And then, yeah,
exactly.
Susie
So,
Q
but
would
this
be,
is
as
an
you said, shining the
example.
light on things.
Yeah. And so this is an example of, so you started with summarize, you started 10,000 feet, and you said like, okay, I want to focus on this little piece, what's this mountain standing here? And you said like, okay, there is 7 different interfaces. You say, what the heck? What is 655.355 and 655.3.6? And then you can say interface show MTU equals, and you can say greater than or equal to 655.3.5, and you will see the ones that have that. And you see immediately that DC Edge 1 has 65536 on some interface called DSC. There is a LO0, and you immediately realize, oh, this must be a Juniper device, most likely. And then there is Leaf 1, which is all loopback 0, loopback 1, which is 65535. And you say, what is device? You know this, but you could say, what is device show? And you will immediately see that DC Edge 1 is VQFX, which is a Juniper device, and Leaf 1 and all the others are VEOS, which are Arista devices. So this is
Hmm.
showing you right away multiple things. First, you went from a 10,000 foot to narrowing down to see what the differences are. You are surprised by what you saw. The next thing you see is all the information, the fact that it was DC Edge 1, which was Juniper, firewall, which is a Ubuntu Linux firewall, and Leaf 1, which is Arista. The information is presented to you in a standardized fashion. So you no longer have to worry about how to look for information. But it's not standardized to the point where it makes no sense. You do have LO and LO0, because if you're a Juniper admin and going to look for things, you do want to see those things. But at the same time, when you say, show me an LLDP peer, and I want to do certain other pieces of operation on an interface, we hide the abstraction of what's on LO0.0, what is on LO. All of that stuff is hidden from you. Because you have an Arista peering with a Juniper, the MTU that you look for is LO0, or the interface .0 on the Juniper side, but the non-dot, there is no .0 on the Arista side. And you got to match all that.
Yep.
We take care of all of that, for example.
Okay.
So we present you an abstracted value, we present you a normalized value, but not normalized to the point where you are like, dude, I want to look at the box and I have no understanding. So it's a very fine art of figuring out what to normalize, parse, abstract, and what to, keep things as they are.
Well, and you've come up with the abstraction based on your own intuition and experience as a network engineer to come up with something that's going to be most helpful for the person sitting at the console.
Absolutely. And the other thing that I thought about right up front is I'm not right. I'm not right a lot of the times. So what I would like to do always is allow for evolution. So the way the schema of SuzieQ is, the way everything is structured, is it's versioned and it is set up for evolution. We find something is different. We say, for example, you want a field that isn't captured today. We just add the field, and you don't have to repopulate the data. You don't have to throw away the existing data. Everything just grows.
So we've got this, that's the summarize feature. You've also showed us how to dig in and find more information there at the CLI.
Yep.
What's next, Dinesh?
So the next thing I want to show you is basically how we do network documentation, which is how SuzieQ pushes information that it has about the network into NetBox. And this is a very common use case we have run into with a lot of people who say, for example, I have 1,000 devices. If network automation was supposed to automate, how do I populate 1,000 devices? There are different solutions available today. SuzieQ offers one because we can do a bunch of different things. And
So,
what I want
so,
to
so hang on. So, just to summarize this, it sounds like you know as SuzieQ lots and lots of things about the network, and you've got an integration with NetBox, so you can take
Yes,
the information in your database and push it
yes,
into NetBox. And now
yes,
I have network documentation that is reflecting the current state of the network as SuzieQ discovers it in
exactly.
NetBox. Okay,
Exactly.
okay.
And as you move forward, we can keep running the check to make sure things have changed or not, and resynchronize if, code and doc change, reality and intent changes. You can always verify that all the time. And because Notabot runs off of NetBox largely, people have been using us to sync with Notabot as well. Not Notabot 2, but with Notabot as well. So NetBox and
So
Notabot.
this is actually interesting. So I can use SuzieQ for initial discovery. If I've got empty NetBox or Notabot, I could begin population of my network documentation database in NetBox or Notabot with SuzieQ, and then on demand I can resync. And as you say, that difference between intent and reality, I can keep those two synchronized.
Exactly.
Well, does that mean data flows the other way too, out of NetBox or Notabot and into SuzieQ to force changes, or just that?
No,
just one way? Okay.
Just one way. So the one thing that SuzieQ does not participate in today, and that is very consciously that way, is we are a read-only system, meaning we only read data from the networks. We don't write data to the network. So we don't configure devices today. There are lots of good solutions out there, and we didn't want to reinvent the wheel. So basically what we do is, but what we can do is compare the values, and in network validation, talk about how we can use what's in NetBox without having to duplicate. And we can do that next. So the next thing I wanted to show you was basically NetBox, how NetBox sync works very quickly. And then we can move to the next stage. All right. So for that, I will switch to the GUI. Like I said, we are very, very agnostic to how you do things. In fact, you can start the NetBox sync in the CLI and finish it in the GUI. It's all integrated and uniform throughout. But let's kind of stick to SuzieQ. So this is a SuzieQ login screen. As you can see, we have a login screen. The enterprise GUI is completely different from those who use the open source. The enterprise has RBACL, has login, and we integrate with third-party enterprise sign-on, single sign-ons, all of that good stuff. So anyway, another day. So basically, you come to this tab called NetBox Sync, and we can sync everything, or we can sync just the device information. So we have options, knobs for you to twiddle to decide how you want to sync. So we say we want to sync everything, and we want to sync here DC2. What I've done, just for grins, is here is a NetBox site where I have just created the API token, but the site itself is empty. So if I click on the site again, there's nothing in here. It's an empty NetBox, okay? So then I go into SuzieQ and I say, basically in SuzieQ, when you're trying to push information to NetBox, we have consciously separated it into 3 separate steps. First, you compute the difference of what is inside the real network and what's inside NetBox. Then you examine it to say, this makes sense, I would like to, or you say like, you know what, that device, I'm going to decommission now. So just don't sync that info into a NetBox. You can turn off things like that. And then you say, now sync it, and then we will sync it. So the first step of that is you basically compute the diff, and essentially it runs and says, okay, we have a bunch of differences to check. And you see that there's a device table, an interfaces table, an inventory. So all of this information we have. You look at, and you can select any one of them, look at what we are going to push, how we are going to push, all of that detail is here. Okay. And once you're ready and you say, this looks good, you say push. And basically, because of certain model differences, like for example, the fact that WRF is global, but IP address is also global, but IP address in reality, if you have multiple namespaces, sites, they can actually overlap without a problem. There are some of those things. So we explicitly say, and there is no API call for us to figure out what knobs have been enabled in NetBox. So we tell the user this pop-up box, are you sure you know what you're doing? Because, if there are duplicates, then you're going to have problems in NetBox, because we don't want to mess up your NetBox. And with the change management that they have introduced now, we can push it to a branch, which is much nicer, but that's to be coming in the next release. But right now, this is 4.1 that we are testing with, 4.1 of NetBox. So you basically say yes, and you say push to NetBox. And now it takes the time to push to NetBox, and takes a couple of seconds, minutes. And it's telling you what all it's pushing. It's pushing devices, interfaces, inventory, all of that good stuff that you saw. And when it's done, it says, hey, I've pushed everything.
Namespace is going to correspond to a site in NetBox, right?
Exactly. Yep. And we provide mapping whereby if you don't believe the namespace and site are the same, you can map from namespaces to a site. All of that stuff works. So we do this and we wait for the sync, and it says sync is complete. And so you say, great, And a simple way to know whether the sync is truly complete is you go back again and you say DC2 and you say compute diff again. Hopefully it says there's no difference, because
Should.
then you know everything is synced and life is good. And so it's comparing again, it's pulling all the data from NetBox because you could have made a change and says there are no differences. This is the first proof of the pudding. The
Excellent.
second is
Yep.
you go into NetBox itself, you click on the site now, and you see that DC2 has popped up.
Mm-hmm.
And then you can click on what are the devices, and you can see all the devices that we had popped up there pop up here too. You can see the model, you can see the manufacturer, you can see the type, you can see the IP address, you can see all of this. And you
Mm-hmm.
can also drill down deeper into things like IPAM and look at what are the IP addresses. And we have shown you the IP addresses. We can also show you VRFs. We can show you VLANs. All of this information is synced. And we also have inventory. Now, obviously, I don't have inventory to show you, but we push in all the inventory information as well.
Neighbors like LLDP?
So LLDP is one that we have not pushed yet because different people have different, there is no automatic LLDP, how shall I say, construct inside NetBox. It has
Okay.
something called cabling, but the cabling can go through a patch panel. So now we have a conflict of
Right.
what we do with cabling. So we did not add it in our first release. So what we are going to offer in our next upcoming release is basically say, you have an option. Let us know if you think you're going to use the cabling as an LLDP sync. And so then we will sync LLDP as well.
Okay.
So, one of the things that I've learned from my long time in the industry is it's easy to add a feature. It's almost impossible to take it away because there'll be some person using it. And now this is how you end up with code bloat, you end up with bugs and all of these things. So I always like to start with the most common denominator, start seeing where people have real needs that are not satisfied by what we have, and then start adding all of those. Adding features is fairly easy for us because of the architecture, but we want to kind of always start simple and keep things only as much as needed.
Got it.
The next thing I want to show is, okay, we pushed all this information. What else can you do now that you've pushed all this information? One of the things that is very useful for, I think, network automation is if network automation is code, then one of the primary tenets of code is you don't want to duplicate information. You want to validate what is in the network. You don't want to repeat information. So if I have my MTU specified in NetBox, I don't want to have to repeat it when I assert what I believe of the network. I just want to say, I want to assert that the value of every interface is whatever NetBox says it is. So we can write a assertion like that, which basically says assert MTU, what the value we assert is match intent, and we figure out for the device the intent is coming from NetBox, and we pull it from NetBox and compare and match it, and then we say pass or fail.
And again, you're not going to push a change down into the network, but you can tell me who, again, pass or fail. Yes, you
Yes,
match intent, or no, your production environment does not match intent. Yeah.
exactly. So I have a running topology, so I could go and change something on the device itself, have SuzieQ pull it in, and then when you say assert, we can say, no, it didn't match because something changed, as an example. So to give you that example, so what I can do here is, again, I'll switch to CLI for fun. And what we can do is we have this thing called assert. You can run an assert, and you are running it across this namespace, and I already have it complete, so I can just hit that. And I basically say assert match MTU intent. And if I hit this, it'll essentially go compare against what's in NetBox for your entire network. You can put in filters if you want. But right now, because we just compared and it said there was no difference between NetBox and SuzieQ, we said everything looks good.
Mm-hmm. Assert passed. Yeah.
Yes, assert
And
passed.
which
You can
there
put
should be no other thing because we just did the sync. So yeah.
exactly. Now, one thing we can do is go make a change on the NetBox side just to fail it, and then run an assert here to see that it fails, as an example.
So changing it in NetBox effectively is changing our intent. We want the MTU on this interface to be some number. You're gonna punch it into NetBox for us.
Exactly. And we want to validate that that's the number that shows up over there. So now I'm going into NetBox again, and I'm going into devices. I'm going into interfaces. And let's just pick one interface. And I'll, for the sake of fun, pick up Ethernet 1. And I'll pick Ethernet 1 on, say, leaf 1, this one. And I'll edit it right now. The MTU, it says, is 9214. I'll just make it 1500 for grins. Okay.
No jumbo frames for you.
No jumbo frames for you if you come on this link. My beautiful script took care of making everything uniform, except it had a bug. I didn't know that. So it got pushed. So now I can switch back to this place, and I can say, check intent again. And you'll see that it'll fail. There, it failed. And then you can say, okay, I'm glad it failed, but what the heck failed? I don't know what failed. So what you can do is you can say detail equals true. And as you can see, everything has completion. So you don't have to know what to do. Everything has completion. And then you can say, I only want to see the results of what failed. And when you hit that, you will see the output show up as there. It says the MTU is 9214. We have an MTU that's 92. It doesn't match intent. So then you say, aha, what the heck happened? You can go back into SuzieQ again and now say, hey, I want you to run sync again on this namespace. And you can say compute diff, and you can see now that it'll run the diff. And something has changed because you did not see the message, nothing has changed. So if you click on interfaces, you'll see that 1500, we are going to push it back to 9214. Okay. And then if you say push to NetBox, it'll push to NetBox that information. And basically at that point, we are back to having the intent and reality match.
Yeah.
So there it is. It's done again.
Very good. So, okay, you showed us a bunch of things here. So a couple of questions for you. One, this is SuzieQ Enterprise. The things you've showed me are distinct from what I can do with SuzieQ open source, correct?
Correct.
Okay. And the next question then is, there's so much more here. I mean, you've demoed a couple of cool features, but there's a ton more that I could be doing with SuzieQ Enterprise. You had a big slide with all those use cases.
Yes.
Yeah.
We don't have the time in the 15, 20 minutes we have to go over every one of them. So, the simplest thing, go onto our website, schedule a demo time with me, and I'm happy to show whatever it is that you want.
Okay. Multi-vendor networks, you're very highly supportive, it looks like, yeah?
Yep. We already showed you the fact that we have Linux servers, where firewalls essentially there. That's just a server. We have Junos, and then we have Arista. And not only do we have that, the other aspect of SuzieQ, the way it has been designed, is every piece is a decomposable piece. Meaning I can change what I want about it without affecting the rest of the architecture. As an example of that, we found that the most efficient way to pull information from Junos is through netconf. So we use netconf to pull information from Junos. We use SSH to pull information from, say, iOS XE, and we use REST to pull the information, or JSON RPC to pull the information from SR Linux. So we don't care what the model is. We can pull the information any way it is available, as long as it's information that we care about, right? I mean, there is stuff you can say, oh, why don't you use SNMP? Because I can't get what I want.
Okay. Now, if you're watching this and you're new to SuzieQ, you've not heard of this networking tool before, go to packetpushers.net and do a search for SuzieQ or search for Dinesh Dutt. Dinesh has been on a number of our podcasts and has talked about SuzieQ in various contexts, and also has strong opinions about network automation, which he shared in various contexts as he's been on different of our shows. So that's worth your time if you're exploring this topic to see what SuzieQ is all about and kind of get your head around network automation and some of the advanced things that are happening in the world these days. Thanks for watching. We appreciate your time. So final question for you, Dinesh, then. Your website, is it SuzieQ.com? Is it Stardust Systems? Where do people go?
People go to stardustsystems.net. You can also go type SuzieQ, and if you go to the GitHub, and there's a link to stardustsystems.net. So stardustsystems.net, request demo, and you're in business.
Yeah, and go request a demo, and you'll Dinesh, you're the one who's going to be doing the demo?
Mostly. I'm getting
Yeah,
other people to do demos now, but mostly me. Yes, still.
very cool. So get some one-on-one time with Dinesh. Sounds good.
Thank you.